My Earth Science faithful, welcome to video number 5. Oh, there's all 5 fingers. And we're on page 10 in our packet. We're going to get into the heating of water today now that we know how much heat it takes to raise the temperature of 1 milliliter of water 1 degree Celsius. That would be the specific heat. Okay, now we know that, we can track the heating all the way through. This is what's called a heating curve. There are always 3 slants and 2 flats. You'll notice the 0 and the 100 are fixed because this is going to be water. Remember, 0 is the freezing point. 100 is the boiling point. That's going to help you see what's going on those flats. And of course, we will dig in deeper next year, but these are this is going to be a good overview for this year. Ready? So bottom slant, always solid. Middle slant, always liquid. Top slant, always gas. As you see, the temperature is going up, so that makes sense. The coldest phase is solid. The medium phase, temperature-wise, is liquid. The hottest phase is gas. You see the 0 and the 100 there, so you definitely need to know that. All right, heat is also being added at a constant rate, by the way. So on the bottom flat, this is the flat piece. This is not, I know it's pointing towards the slant, but it's not. At the bottom flat, when I go from solid to liquid, we call that melting. And if you use water, you know solid water is called ice. And when I go from solid water to liquid water, we call that melting. So a lot of these things you already should kind of know, right? And when I go from liquid water to gas, science word vaporization, you guys could call that boiling if you'd like, because that's what you know, and I'm cool with that. Notice the energy is different to make both things happen. This is on your reference table, by the way. This is on the front page of your reference table where it says properties of water. And these numbers are the same for chemistry when we get to use those. I will just give you less numbers. You'll just see it's like repeated for energy gained and released. Well, gained is plus, released is minus. So I'm only going to give you the one number, and it's up to you in chemistry to figure out which way we're going. See what I mean? So there are multiple things happening at this bottom flat and the top flat. When I go backwards on this chart, if I started at gas and go down to liquid, that's called condensation. And if you're not really sure you know about condensation with that word, I know you know condensation. Let me give you 2 examples. First example, I bet you know. You got a glass of iced tea or maybe a soda in the summertime outside. You didn't spill any, and all of a sudden, beads of water are on the outside of your drink. That's condensation. That's gas water turning into liquid water because the liquid in your glass or can is colder than the air. Here's another one I know you guys have all done. Ready? Watch. Sitting in the car or in a bus, there's a window, you go like this. You draw a little heart or you draw your name, right? That's condensation. You're turning vapor water in your lungs when you breathe into liquid water. So I'm sure you know, have some experience with condensation. You just might have not known that that's the word. Then we call this solidification, or you can call this freezing when I go from liquid water to solid water. That's freezing, or you could call it solidification. I mean, I would call it freezing. The melting point and freezing point are the same point. They both happen at 0 degrees Celsius. Now, the difference is the arrow and the sign on those the number of energy. If I'm heating, it's melting, and if I'm cooling, it's solidification. So like we could actually do this whole chart the other way and do it a cooling curve, still 3 slants, 2 flats, and that's how this game is played. Okay? Here is a picture of your properties. Okay? Notice it gives you the density specifically at, we call that 4 degrees Celsius between friends. That is when water is 1 gram per milliliter. Melting. So what you need to know for melting, changing from liquid to solid. I'm sorry, solid to liquid. Solidification, no joke. I would call this freezing. So this is freezing or crystallization, changing from liquid to solid. Vaporization, and it actually says in your paper evaporation, but that's kind of it's the same thing, but evaporation tends to happen based on gradient differences where like the air's drier than the liquid and so it evaporates off. Vaporization implies I'm putting heat in where evaporation doesn't necessarily do that. So if you want to cross off evaporation in your notes and write vaporization, I mean that's a better word. And then, oh, look, evaporation, changing from liquid to gas. That's the most important piece. I would also write boiling. That's what's happening. Condensation, changing from gas to liquid. Oh, and sublimation, we have not talked about this yet. And we don't have, oh, wait, melting, freezing, vaporization, condensation. All right, good, good, good. Oh, sublimation. Sublimation is when I go directly from solid to gas. Uh, it skips the liquid phase. The most cliched example I can give you for sure is always dry ice, carbon dioxide. We'll go from solid carbon dioxide directly to smoking, and it won't hit the liquid phase at all. Not everything sublimes, by the way, but it's special phase change. With that, we are done with page 10. On page 11, you have some properties of water to fill out, and we will get on to page 12 notes next.